Neptune, the eighth planet from our sun, a giant ball of blue. It seemed calm and peaceful, a quiet giant in the vastness of space. Astronomers observed Neptune from afar. They saw faint rings and a few moons, but the planet seemed relatively uneventful. It was a quiet neighbor in our solar system, or so we thought. In 1989, our perspective changed dramatically. NASA's Voyager 2 spacecraft reached Neptune. It sent back incredible images that shocked the world. There, in Neptune's southern hemisphere, was a massive storm, a swirling vortex of dark clouds. We called it the Great Dark Spot. The discovery was astounding. A storm of such magnitude was unexpected. It was a stark contrast to Neptune's previously assumed calm nature. This wasn't just a small disturbance. It was a giant raging tempest, a sign that Neptune was far more dynamic than we ever imagined. Voyager 2 had a front-row seat to this cosmic spectacle. Launched in 1977, this spacecraft embarked on a grand tour of the outer planets, and in 1989 it reached Neptune, the eighth planet from the Sun. This was a historic moment, as it was the first time humanity had ever closely observed this distant world. It captured detailed images of the Great Dark Spot. The storm was enormous. This massive storm, similar in appearance to Jupiter's Great Red Spot, was a swirling vortex of dark clouds, revealing the dynamic and turbulent nature of Neptune's atmosphere. It was estimated to be about the size of Earth. Imagine a storm so vast that it could engulf our entire planet. This comparison highlights the sheer scale and power of Neptune's atmospheric phenomena. Winds raged within the storm at unimaginable speeds. These winds, driven by Neptune's rapid rotation and internal heat, created a chaotic and violent environment unlike anything we experience on Earth. Voyager 2 clocked them at over 1,500 miles per hour. This incredible speed is more than twice the speed of the fastest hurricanes on Earth, showcasing the extreme conditions present on Neptune. These were the fastest winds ever recorded in our solar system. Such record-breaking wind speeds provide valuable insights into the atmospheric dynamics of gas giants and the forces at play in their weather systems. The data sent back by Voyager 2 was invaluable. It offered a treasure trove of information that scientists could analyze to better understand Neptune and its complex atmosphere. It allowed scientists to study the storm in detail. By examining the data, researchers could delve into the intricacies of the storm's formation, its energy sources, and its potential longevity. They began to understand its structure, its behavior, and its potential impact on Neptune's atmosphere. This knowledge not only enhances our understanding of Neptune, but also contributes to our broader comprehension of planetary atmospheres and weather patterns across the solar system. Section 4, A Tale of Two Storms, Neptune versus Jupiter. The Great Dark Spot reminded us of another famous storm, Jupiter's Great Red Spot. Both were massive anticyclones, giant high-pressure systems churning in the atmospheres of gas giants, but there were key differences. The Great Dark Spot on Neptune was much smaller, much darker in color, and moved much faster across Neptune's surface. These differences intrigued scientists and provided clues about the unique atmospheric conditions on Neptune. Section 5. Neptune, a more dynamic world than we thought. The discovery of the Great Dark Spot was a game changer. This massive storm, comparable in size to Earth, was first observed by the Voyager 2 spacecraft in 1989. It revealed that Neptune was not just a distant, cold and quiet planet, but one with a dynamic and active atmosphere. It forced us to reassess our understanding of Neptune. Scientists had to go back to the drawing board, re-evaluating their models and theories about the planet's atmospheric conditions and weather patterns. The planet was not a placid blue giant, it was a dynamic and turbulent world with a complex and ever-changing atmosphere. The Great Dark Spot was just one of many storms that raged across Neptune's surface, driven by winds that could reach speeds of up to 1,500 miles per hour. The storm provided insights into Neptune's powerful winds and showed us that the planet's atmosphere was much more active than we thought. These high-speed winds were unlike anything seen on other planets in our solar system, making Neptune a unique subject of study. The discovery also raised new questions. What caused these massive storms? Were they driven by internal heat sources, or were they the result of complex interactions between the planet's atmosphere and its magnetic field? How long did they last? Some storms seemed to persist for years, while others appeared and disappeared within months. Understanding the lifespan of these storms could provide clues about the underlying mechanisms driving them. How did they affect Neptune's overall climate? The presence of such intense and long-lasting storms suggested that Neptune's climate was far more complex and variable than previously thought. Researchers continue to study these phenomena to unlock the secrets of this distant, dynamic world. Section 6. The Universe, an Ocean of Discoveries. The vast expanse of the universe is like an endless ocean, filled with countless stars, planets, and mysteries waiting to be uncovered. Each celestial body holds secrets that can change our understanding of the cosmos. The great dark spot on Neptune is a reminder that the universe is full of surprises. This massive storm, similar to Jupiter's great red spot, showcases the dynamic and ever-changing nature of our solar system. It serves as a testament to the fact that there is still so much we have yet to learn about the planets that share our cosmic neighborhood. It highlights the importance of exploration. Human curiosity drives us to venture into the unknown, to seek out new frontiers, and to push the boundaries of what we know. The bravery of astronauts and the ingenuity of scientists and engineers make these journeys possible, allowing us to gather invaluable data and insights. The more we explore, the more we realize how much we don't know. Each discovery opens up new questions and challenges our existing theories. Scientists and researchers tirelessly analyze data, constantly refining our understanding of the universe. Their work is a continuous process of learning and discovery. Every new discovery brings new questions and pushes the boundaries of our understanding. From the smallest particles to the largest galaxies, each finding adds a piece to the puzzle of the universe. The animated orbits of planets remind us of the intricate dance of celestial bodies governed by the laws of physics. The journey of discovery is never-ending. As our technology advances, so too does our ability to explore further and deeper into space. Spacecraft travel through the vastness of space, capturing images and data that expand our horizons. The time lapse of the night sky illustrates the passage of time and the ongoing quest for knowledge. As we continue to explore our solar system and beyond, we can be sure of one thing: there will always be new wonders to uncover, new mysteries to solve. The images captured by space probes and the observations made by astronomers using powerful telescopes provide us with glimpses into the unknown, fueling our desire to learn more. The universe is an ocean of discoveries, and we are just beginning to chart its depths. Just as explorers of old sailed uncharted waters, we too are navigating the vastness of space, driven by the same spirit of adventure and curiosity.